Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, we want to present our group assignment for subject statistic for real estate management. Before we start, I want to introduce our team. My name is Imanur Ashraf bin Zulkifli, and the other members is Muhammad Adib Ehsan bin Akmal Arifin, Muhammad Abi Muhaimin bin Osman, Muhammad Adib Hazim bin Ramli, and the last Muhammad Daniel Akid bin Zanif.
For the introduction, simple linear regression is a statistical method to make predictions on basis data and allows us to summarize and study relationships between two continuous quantitative variables. One variable, denoted as X, is regarded as the predictor, explanatory, or independent variable. The other variable, denoted as Y, is regarded as the response, outcome, or dependent variable. A simple linear regression is a statistical technique used to find relationships between variables for the purpose of predicting future values. It enables us to see the trend and make predictions on the basis of data.
Next, for the methodology. The method that we use is by delivering Google Form questionnaires to UTHM students on WhatsApp and Telegram. The objective of this assignment is to learn more about student study hour and grades achieved during the last semester. The number of responses that we obtain from the Google Form questionnaires is 30 students of UTHM. This table shows student data about the students' study hours and the grades they achieve. We have collected this data by sending a Google Form link that contains questions about their study hours and the grades they achieve. The total sample we obtained from Google Forms was 30 students. Next, I'm going to explain a scatter plot. A scatter plot is a graph of ordered pairs, x and y, of numbers consisting of the independent variable x and the dependent variable y. This is data of the relationship between students' study hour and their grades achieved. X is student study hour independent variable and y is grades achieved dependent variable. Simple linear regression model. For simple linear regression model, simple linear regression is a statistical technique used to find relationships between variables for the purpose of predicting future values. In addition, it allows us to see trends and make predictions based on the data that has been obtained. Y is denoted as dependent or response variable to be modeled, and X is denoted as independent or predictor variable used as a predictor of Y. The least square method. The method of least squares is a standard approach in regression analysis to approximate the solution of overdetermined systems, sets of equations in which there are more equations than unknowns. Least squares means that the overall solution minimizes the sum of the squares of the residuals made in the results of every single equation.
Okay, for the question B, when mean n equal to 30,
y bar equal to summation of y divided by n equal to 103.9 divided by 30, and we get 3.46. Next, x equal to summation of x divided by n equal to 147 divided by 30, and we get 4.9. Then y-intercept equal to beta 0 plus beta 1x. In this question, we use formula 1, which is sxy equal to summation of xi minus 1 divided by n, open bracket, summation of xi, close bracket, summation of yi, close bracket. Summation of xy equal to 533.2. Next, summation of x equal to 147, and the last one is summation of y equal to 103.9. Then xxy equal to 533.2 minus 1 divided by 30, open bracket, 147, close bracket, open bracket, 103.9, close bracket, and the final answer is 24.09. Okay, and then we got 24.09. We move on to formula 2, which is sxx equal to summation of xi to the power of 2 minus 1 divided by n, open bracket, summation of xi, close bracket, to the power of 2. Then x summation of xi to the power of 2 is equal to 825, and summation of x equal to 147, which sxx equal to 825 minus 1 divided by 30, open bracket, 147, close bracket, to the power of 2, which we got 104.7. Okay, for formula 3, beta 1 equal to xxy divided by sxx, which is 24.09 divided by 104.7, which we got 0.23. And for formula 4, beta 0 equal to y-intercept of y minus beta 1x, which is 3.46 minus 1.23, open bracket, 4.9, close bracket, and we got 2.33. And for question 5, which is the final answer, beta 0 plus beta 1x, which is 2.33 plus 0.23x. Okay, for the question C, we'll find determination and coefficient. The first is determination. We use formula r to the power of 2 equal to, in bracket, xxy to the power of 2 divided by sxx times syy. We know that the value of sxy equal to 24.09, and the value of sxx equal to 104.7, and we need to find the value of syy. To find the value of syy, we use summation of yi to the power of 2 minus 1 divided by n times summation of yi to the power of 2. Then we got summation of yi to the power of 2 equal to 366.47, and summation of yi equal to 103.9. syy equal to 366.47 minus 1 divided by 30 times, in bracket, 103.9 to the power of 2, and we got 6.63. Then we move back to r to the power of 2, which is equal to, in bracket, xxy to the power of 2 divided by sxx times syy, which is 24.09 to the power of 2, in bracket, divided by 104.7 times, in bracket, 6.63, and the final answer is 0.84. We move on to the coefficient. We use formula sxy divided by square root of sxx times xxy. We know the value of sxy equal to 24.09, and sxx equal to 104.7, and the last one is syy equal to 6.63. So r equal to sxy divided by square root of sxx times syy.
equal to 24.09 divided by square root of 104.7 times 6.63, and we got 0.91.
Based on our initial analysis of the data set containing 30 samples, we observe a positive correlation between the number of hours a diligent student spends studying, represented by X, and their excellent grades achieved in semester 1, represented by Y. This led us to formulate the following hypothesis regarding the relationship between study hours and academic performance. Okay, that's all from us. Thank you.